Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5, and this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25, and this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125, and this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer. Alright, so in this video, I'm going to solve the equation x to the power of 3 minus 8 is equal to 0. So how most people solve this equation is they add 8 on both sides. So I get x to the power of 3 is equal to 8. And then they take the cube root on both sides. So the cube root of x to the power of 3 is x, and the cube root of 8 is 2. So then they get x equals 2, which is a solution to this equation. But actually, there are more than one solution to this equation. So I'm going to rewrite my equation here, x to the power of 3 minus 8 equals 0. And now I'm going to rewrite 8 as 2 to the power of 3. So I get x to the power of 3 minus 2 to the power of 3 is equal to 0. And then now I'm going to use the formula a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So in this case, this turned into x minus 2 times x squared plus 2x plus 4 is equal to 0. So now I get two equations. I get x minus 2 equals 0 and x squared plus 2x plus 4 equals 0. So for x minus 2 equals 0, I get x equals 2, which was a solution that we already got. But now see, on top of this, we have a whole nother equation with two more solutions because it's a quadratic equation. So to solve this, I'm going to use the quadratic formula. So I get -2 plus or minus the square root of 2, which is 4, minus 4 times a, which is 1, times c, which is 4, all over 2a, so 2 times 1. And this turns into -2 plus or minus the square root of 4 minus 16 over 2, which is equal to -2 plus or minus -12 over 2, which is equal to -2 plus or minus 12i over 2, which is equal to -1 plus or minus 6i. So these are the two more solutions to this equation.